polyhedron that we're going to study is the sphere. So we're going to learn about the surface area and the volume of the sphere. So it's our last 3D shape that we're going to study. So remember, when we're talking about volume, we're talking about how many cubic units that it takes up, and in terms of how many cubic units it takes up, we're also talking about the amount of space that it takes up, because it's 3D, right? And we're talking about a sphere. Think soccer ball, tennis ball, golf ball. They're all smoothed out around the edges, as opposed to a football or a rugby ball. So you want something that's perfectly circular in 3 dimensions, which then forms a sphere. So it says here, imagine a sphere has been placed inside a cylinder. It's the diameter of the base of the cylinder. So here's the diameter of the base of the cylinder. And the diameter of the sphere are equal. And the diameter of the sphere are equal. So here's the diameter of the sphere. So we can draw the diameter of the sphere this direction. We can draw it this direction, right, over your radius. You can also draw it this direction. That's also the diameter of the sphere going from top to bottom. So if the diameter of the sphere and the diameter of the cylinder are equal, then which shape would have greater volume? Well, hopefully this is very obvious to you. You know, if you put this sphere inside the cylinder, then you have all this little empty space in these corners going around the sphere inside that cylinder. So obviously the cylinder has greater volume, right, because of that empty space. So it says mathematicians have determined that the volume of the sphere is actually 2/3 the volume of its corresponding cylinder. So what does the word corresponding mean? Well, that means it's a cylinder with the same diameter and height. So the cylinder has a height that is the same length as this diameter going across from it. So these two measurements are the same. And notice that is also the diameter of the sphere. For the sphere to fit exactly inside the cylinder, the diameter of the sphere must also equal the height of the cylinder. That's what I was just saying. So this diameter of the sphere right here is equal to the height of the cylinder. So let's use this knowledge to develop the formula for the volume of the sphere. So we just said the volume of the sphere is 2/3 the volume of the cylinder. Well, we know from previous class that in order to find the volume of the cylinder, we have to multiply pi r squared h. Okay, but we just said that the height is the same as the diameter of the sphere. So, and what is the diameter of the sphere? The diameter of the sphere is twice the radius. So in other words, we can substitute in twice the radius for our height, because this is 1 radius and this is 1 radius, which is also equal to the height of the cylinder. And then if we simplify that, well, we're going to multiply 2 times 2, which is 4, so we get 4/3 pi. And then we have r cubed times r, which is r cubed. So the volume of a sphere is 4/3 pi r cubed. So the theorem says the volume of a sphere equals 4/3 times the cube of the radius. So the cube of the radius, again, because it's 3-dimensional. So here, in terms of the formula, you would put 4/3 pi r to the 3rd power. And now we're just going to use that formula to solve the various problems. So let's look at this first page. You can either pause and just try it on your own and then check your answers, or you can go through the examples with me now. So it says, determine the volume of each of the following spheres, give answers as an exact value or round to 2 decimal places. So we have our radius here, which is 5 units. Notice in a sphere, this should have been a dotted line. It was trying to show you the 3-dimensional part of it, the depth in there. But I couldn't do the dotted line on the diagram. So if we're trying to find the volume, well, we just said above that the volume equals 4/3 pi r cubed. So what is r? R is 5. So we're just doing a basic substitution. So 5 cubed is 125. 125 times 4 gives us 500. So we get 500 pi over 3 centimeters cubed. If you're leaving it as an exact answer, that's what the volume would equal. if you wanted to use your calculator and round, then you should get 166.767 centimeters cubed. Somehow that looks very wrong to me, but I don't know. So check it, maybe that's wrong. Okay, the next one, circumference. So it says this time instead, this is a little more interesting because you've been given the circumference. So what circumference? Well, the circumference right around here at the widest part of the sphere. So not up here somewhere, but this widest part of the sphere, right in the middle. So that means we don't know this radius, so we have to solve for the radius. So remember, circumference equals 2 pi r. Well, what is the circumference? It's 59.7, so we substitute that in for c. And now to isolate r, we have to divide each side by 2 pi. So grab your calculator, divide each side by 2 pi. Remember, you either parenthesize that value, or you divide 59.7 divided by 2, push enter, 59.7 divided by pi, push enter, and you should have gotten something like 9.50155, etc. But that's not the answer I wanted. I wanted the volume. So now I have to use that. Remember, you can store this value in your calculator so you don't make any rounding errors. So store that value in your calculator if you want, or recall it right away. But we're going to plug in that value into 4/3 pi, 9.501, blah, 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 to the third power. So what do you get when you do that? You should get 3,593.12 centimeters cubed. So this isn't a very nice problem to leave in exact form. You could, but you would have pi squared in the denominator and all this other stuff, 59.7 times. You have a decimal and a fraction, and that doesn't really work. So this is best to round to 2 decimal places, and you get 3,593.12 centimeters cubed. Okay, moving on. So surface area, we just did volume. Volume is 4/3 pi r cubed. Surface area is just the area of the sphere equals 4 pi times the square of the radius. So translating that into formula form, what do you get? Well, it's 4 pi times the square of the radius. So it's just 4 pi r squared. So if you wanted to prove that at home, well, you could take 4 apples, find the circumference of the apple, use a compass, measure out 4 exact circles with that same circumference, and peel the apple and place the peels in there and rip them apart until you fill it up all 4 circles. But you're probably not going to do that, so you can just trust me that the answer is 4 pi r squared for the area. So determine the area of the following spheres, give answers in exact form or 2 decimal places. So this time, very simply, the area is 4 times pi times 5 squared. Well, 5 squared is 25. So 25 times 4 times pi. So that's 100 pi. And this time, because we're talking about area, we should have a centimeters squared. So something to the 2nd power because it's 2-dimensional. The surface area, the area on the outside. And then our circumference is 59.7. Well, let's go back and recall what we got for that radius. Maybe it's still stored as a value in your calculator, which is awesome, that 9.50155. We already did set this equal to 2 pi r, right? We already did this step on the front page and solved for r. R was 9.51055, etc. So what are we going to do? We're just going to plug that in into 4 times pi times 9.51 squared. So when you do that, you should have gotten about 1,134.49 centimeters squared. Okay, so those are very straightforward. Number 3, it says a sphere has a surface area of 300 centimeters squared. Determine its diameter. So what do? Well, we take the 300 and set it equal to the formula of 4 pi r squared. Now we have to isolate the r because r is what's in here. Once you get r, you can double it. So I isolate my r. divide each side by 4 pi, I get r squared equals approximately 23.873, blah, blah, blah. Now what do you have to do? You have to take the square root of r, so use your math go to your math button on a TI-84 and go down to the square root symbol, or on your TI Inspire, it's on the left-hand side. So you should get that r is approximately 4.886, etc. But that's not what the question asks. The question asks for the diameter. So remember, the diameter equals twice the radius, so we're going to multiply this value by 2. So then when I round it to 2 decimal places, I get for my final answer 9.77. And then remember, it's a single dimension, so it's just centimeters to the first power. For the next one, a hemisphere. Well, here's the trick about a hemisphere. A hemisphere is half a sphere, as you can see here. But remember that the hemisphere has this base on the bottom that's a circle. So when you're finding the hemisphere, it says a hemisphere with diameter 15 meters needs to be painted. Determine its surface area. Don't forget to add the circular bottom. So we are going to paint the outside of a hemisphere, the bottom, as well as around the spherical part. So you have a circle on the bottom as well as a spherical part. Well, we know the surface area for a sphere is 4 pi r squared. But we only want to do half that sphere, because that's what a hemisphere is. So we divide it by 2. But then we're going to add on to it the circular bottom, which is just pi r squared. And remember, this radius is the same as this spherical radius, so it's all the same radius. So when we divide 4 by 2, we get 2 pi r squared plus 1 pi r squared. So the total surface area of a hemisphere, including its circular base, is 3 pi r squared. So now what do? Well, if the diameter is equal to 15, we half that to get the radius. And now in order to plug it in, the area would equal 3 times pi times 7.5 squared. So you should get, for your final answer, rounded to 2 decimal places, 530.14 centimeters squared. Now I'm going to pause. Go ahead and try these last, the number 5, A, B, and C on your own, and then come back and see how you did. Okay, you can pause here and check your answers if you've already done them. But in this first one, they gave you the volume, so you have to set the volume equal to 4/3 pi r cubed. We have to isolate r cubed. That means dividing by 4/3 and pi. So I need to take this value, divide by 4/3, and also divide by pi, so you should have gotten about 1,728 exactly. Now you have to take the cube root, not the square root. So in order to do that, you should have went to your TI-84 math button, and I think it's number 4 or number 5. Mine's out of battery, so I can't check. Or in the TI Inspire, it's on the left-hand side in blue. It's the control caret key, and you have to type in the number 3 and then put in this number. So when you take the cube root, you should have gotten 12 centimeters. If you have trouble with the calculator, just ask your teacher. Okay, now that we got our radius, well, we can determine the surface area of the ball really easily. You just plug in the 12 for the radius, so it's 4 times pi times 12 squared. That's 144 times 4, so we get 576 pi centimeters squared, or the rounded answer would be 1,809.56 centimeters squared. And then finally it says, determine the surface area of the smallest box that the ball could fit into. That means the ball would touch the top, bottom, right, and left of that box. Well, if the radius of the ball is 12 centimeters, then that means the diameter at the smallest has to be 24 centimeters. And that means also the height of the box has to be at least 24 centimeters. And the depth of the box here, from front to back of that sphere, the diameter again is 24 centimeters. Well, so it's making a cube. So each face of the cube is 24 by 24. And how many faces do we have? We have 6. So it's 24 times 24 times 6. So my total is 3,456 centimeters squared. So that's it. Get started on your homework, the book work, and make sure you ask your teacher if you have any questions. Bye.